Allora, benvenuti a tutti. Questo ormai non è ovviamente un breakfast, non è un lunch, siamo ormai su quasi la pericena, un digital, per una pericena digital. Ospite Giuliano Orzan di SolarEdge, che ci racconterà le soluzioni e le problematiche che ci sono nell'efficientamento energetico in campo residenziale e la visione, le soluzioni che loro hanno messo in campo in quest'ottica. Quindi do il benvenuto e ringrazio molto di essere intervenuto, di essere con noi. Direi di dargli subito la parola in modo tale da partire immediatamente, visto che poi abbiamo anche altre attività. Quindi, grazie ancora, prego.
Perfetto, è un onore e ringrazio voi per l'invito ovviamente a questa interessante iniziativa. Mi presento rapidamente, io sono il responsabile della divisione residenziale, sono ingegnere e quindi parleremo oggi della soluzione ottimizzata SolarEdge, quindi quelli che sono gli impianti ottimizzati con l'integrazione non solo della produzione dell'energia, ma anche la gestione dei carichi. Quindi integrare la produzione da fonti rinnovabili con la gestione dell'energia e l'interfacciamento con la realtà, con il mondo dell'impiantistica termica, che molto spesso è un parametro che non viene collegato, ma che oggi riteniamo sia fondamentale con l'integrazione della produzione da energia fotovoltaica. Quindi il contesto sarà quello del fotovoltaico integrato in una soluzione a 360 gradi. Quindi io direi innanzitutto presento brevissimamente con solo una slide quella che è l'azienda. SolarEdge è un'azienda fondata in Israele, a Tel Aviv, quindi un'azienda...
Ingegnere, posso chiedere solo la gentilezza se controlla l'attivazione dei sottotitoli, perché tra i partecipanti ci sono anche persone che non parlano l'italiano.
Bene, il collega del marketing mi ha garantito che erano già attive.
Ha mentito spudoratamente.
Ha mentito.
Devi andare su slideshow
Perfetto, grazie.
e in basso non ha i sottotitoli. Non c'è la possibilità di attivarli, mi dispiace.
La possiamo fare in inglese se volete.
Se possibile, sì, grazie.
Ok, allora switchiamo. Ok. Okay, really sorry for this technical issue. Just to a quick introduction to SolarEdge. SolarEdge introduced first in the photovoltaic industry the concept of optimization at module level, introducing the power optimizer. Power optimizer is an electronic component that makes PV modules smart, making more energy and making higher control on the PV system. SolarEdge produced and shipped globally since 2010 more than 60 million of these electronic components, becoming the #1 solar inverter supplier globally in the world. So SolarEdge, it's the first #1 in the inverter industry. Here you have a lot of numbers that can report the company development. More than 2.4 million of inverters shipped globally. We have rep offices in more than 28 countries. Another number that, in my opinion, is very interesting. It's regards the patents awarded. Currently, we have registered more than 358 patents. So it means that SolarEdge It's for SolarEdge, the focus on R&D and the research and the developing of new products. It's in our DNA. It's our target, and we try to be close to the market request and presenting new products and new technologies. Currently, there are still more than 280 patents pending. So it means that SolarEdge doesn't stop, and it's continuously developing new products and new solutions. So we are very proud of that. That's research and development never stop, and it's day by day in developing. We are worldwide. SolarEdge is a worldwide company. We have more than 33,000 partners, installers, partners. We have systems installed in more than 133 countries. In Italy, our office is based in Treviso, but currently we have a team of more than 30 people that are coming basically for different regions in Italy. So we have a presence in all the area, and basically from Italy we are managing southeastern Europe. It means from Portugal, Spain, France, and Romania, Eastern Europe, Black Sea. So this is the region that we are managing from Italy. Let's go back to the technology and the SolarEdge solution. So how it works and how SolarEdge is different from the traditional inverters, for the traditional photovoltaic inverters that are in the market. Basically, these inverters have limitations. Basically, the first one is the energy loss, meaning that the traditional string inverters have find the point of maximum power output, what is currently called MPPT, maximum point of tracking, at string level, not at module level. That means that if there is a weak module, a weak panel, this panel is affecting currently the production of the entire string. Okay, these characteristics prevents the module to reach their maximum theoretical potential production. Okay, with traditional inverter, there are a lot of constraints and limits in design. Basically, in a traditional inverter, you have, let's say, 1 or 2 MPPT trackers. It means that you can have maximum 2 or 3 different expositions in the roof. And this is a big constraint that the use of the roof is usually limited. Okay, moreover, you don't have any information at module level performance. There is monitoring regarding the total inverter production. You can have information regarding the string production, but no information regarding the module level performance. Last but not least, there is safety hazards. As you know, photovoltaic strings on the DC, it may reach very high voltage on the DC side, and even if the inverter is off, you can stop the current on the DC side, but the voltage is still at a very, very high level that can be really, really dangerous. So these are basically a limitation of a traditional inverter. This is the SolarEdge solution. The idea was to split the inverter functionality into the first one is the power optimizer that perform the MPPT tracker at module level, and a simplified inverter that is responsible only for DC-AC conversion and grid management. So you can see in the picture the power optimizer. This is the component that is connected to every PV panel, and the inverters. There are two versions, basically three-phase one for commercial applications on the left of this slide, and let's say the single phase version that is presented here, and basically which is used mostly for residential application. The system includes the monitoring platform. So basically, since the beginning, SolarEdge has a monitoring solution. It means that monitoring a communication board that is embedded in the inverter. Connecting this inverter to the internet, we can have all the production, the information regarding the production at inverter level, at string level, and we can have also the data of production per each module. So actually, I can know exactly how much energy is producing every module on the roof, on my house, or in an industrial building. This is very important because I can check the production of the system and have a detailed control of the performance of the system, of course. Let's go deeper in detail, and let's take a look to the concept of operation, meaning that how the SolarEdge system works. This is the system topology for a single phase inverter. In a traditional system, modules are connected in a string, and then the string is connected to the inverter. In a SolarEdge topology, we have power optimizers that are connected in a string, and every module is connected at the input of the module. So as I told before, power optimizer, it's a DC-DC buck boost converter. It's a electronical component that is performing the MPPT tracker at the input. It means that it harvesting the maximum energy from every PV module. So there is a MPPT level from 8, for instance, to 48 volts for these power optimizers. Of course, we have different power optimizers that are compatible with different kinds of module, of course. At the string level, at the output, the power optimizers can reach from 1 up to 60 volts. One of the main technical characteristics of the single phase inverter is the fixed voltage on the DC side. Usually an inverter has a lower and higher voltage, and it's changed this voltage according with the energy on the string. The SolarEdge inverter has a fixed voltage on the DC side. This allows maximum energy harvesting and allows to have the maximum design flexibility. Okay, let's see how it works. So this is the wake up process in the morning when the sun is rising up. This is night mode. Every power optimizer has an output of 0 volts. Of course, the inverter is in a night mode, so it's in standby. Once the energy from the module allows to reach at least 1 volt output from the power optimizer. When the inverters let's say, measure the voltage that is bigger than 6 volts for the single phase and 9 volts for the 3-phase, the inverter starts the process of wake up from night mode and starts sending the wake up signals to the DC line. So this wake up signal turn on the power optimizer, starting bringing the energy from the modules to the inverter. The target is to bring as much as possible energy for the modules and then convert it on the AC side. So once the power optimizer receives the wake up signal, it performs. So it starts to converting from the module, the input and the output. It calculates the optimum voltage in order to activate the inverter. Okay, I would like to show you which is let's say the behavior of the system in a standard environment. As I told you, so the SolarEdge solution has a very important safety solution. Once the inverter is turned off, okay, from every power optimizer, you have maximum 1 volt of 1 volt per each power optimizers. So let's assume to have a traditional inverter. The VOC, the open circuit voltage for output from a panel, it's between 39 and 45 volts. Let's assume to have 10 modules. You have a voltage that is higher than 400 volts. That could be really, really dangerous in case of installation or maintenance or emergency. With the SolarEdge solution, once the inverter is off, you get 1 volt from every power optimizer. That is considered according with the Italian technical rule, is safety extra low voltage. It's a very safety solution. Okay, let's assume this is an ideal system. Okay, with 10 modules. Each module has 280 watt of power, nominal power. The power optimizer is performing, on the left you have that curve that is a typical behavior of a PV module. There is a specific characteristic of current and voltage that reach the maximum power output from a module. It's called the IV curve. Okay, so there is a specific curve for that irradiation that allows to get that power from the module. So as I told you before, the power optimizer is performing the ideal, the best point of work.
Mi sa che è crashato.
We have lost. Ok. Mi sentite?
Sì.
Okay. Okay, let's start from here. We said that at the input, the power optimizer will calculate the MPPT, so the maximum point of production. That points is at 9 amps and 31 volts. Okay, that's happens at the input. Let's see what is happening on the DC side. On the DC side, the inverter has a fixed voltage that is 380 volts. Considering that the nominal power is 280 multiplied by 10, so 2,800 watts of power, if we divide the power by the voltage, we can calculate the current that is the current that we have on the string level, that is 7.4 amps. The optimizer will measure that current and will calculate that voltage. You know that the power is equal to voltage multiplied by current. According with this relation, this formula, is calculating the output voltage, and every voltage will be the same in this ideal system, okay? But an ideal system basically doesn't exist. Why? Because I can have different irradiation on a PV module. We can have a shadow that is hitting a module. We can have soiling, for instance, or different temperature in a PV module. So actually, in a real life, every module has a different IV curve. That on a traditional inverter, every change of this curve is affecting the production. With Power Optimizer, every module is independent. So a weaker module is not affecting the entire string. So let's assume that we have a shadow on a specific module. The power is decreasing by 50%. So we have 140 watts of power out from a PV module. In a traditional inverter, that will affect all the string. So all the string will be 50%. Okay. With SolarEdge, the Power Optimizer will calculate a specific IV curve at 20 volt and 7 amps. On the DC side, the inverter is keeping the voltage constant. The power will be lower because we have 140 watts of power less. With the new power, we will make the same calculation. So we'll divide 2,660 by 380. And we find the new current. The new current is basically 7 amps. The Power Optimizer that are currently irradiated by the sun will do a boost of voltage. The module that has a shadow, it will decrease the voltage. So basically, the optimizer works as boost and back of voltage. That makes all the voltage contribution, it keeps the voltage constant. Just to make it simple, in a traditional inverter, the shadow is affecting all the modules. With the Power Optimizer, we have a shadow, or let's say less production on a specific module. This loss of energy, it's not affecting all the modules in the string. Moreover, having this fixed voltage, we can have longer strings. We can install modules on a different expositions and inclinations. Let's think to a roof, to a traditional roof, where we have antenna, chimney. We have 3 or 4 different expositions. With SolarEdge, with this solution, you can install modules on every exposition, and every module will perform at the maximum level. So this is the idea behind the module power level optimization. Okay, we can discuss later on if you have specific questions regarding the concept of operating. Let's go to the integrated energy solution. So, which is the proposal? So it is not only an inverter and a power optimizer, but it's a 360 integrated solution. We are proposing basically modules, PV modules with integrated power optimizer. We are proposing hybrid inverters that can be connected to a battery, to a residential storage system. We have inverted that already integrated a device to charge an electrical vehicle, so an integrated wall box. We have application for smart energy management. So this is, let's say, the ecosystem SolarEdge that can manage all this functionality using one app for the smartphone, or only this one monitoring platform. So you can control all these devices using one app or using the monitoring platform. Let's think about all this technology. Currently, we have the app for manage the PV, the app for manage the storage, the app to manage the EV charger. All these functionalities are in only one app. Okay, let's talk about solutions to increase the self-consumption. Okay, so this is the typical production, the production of a PV system. Okay, and this is a typical, let's say, behavior of consumption and system production. So basically, energy is the energy consumption. It happens when the system is not working, so it's not producing energy. So how we can improve, how we can increase the self-consumption of the system? So for sure, the first way to increase the self-consumption is to store the energy, the excess of energy that it would be fed in the grid. We can store that energy in a battery, okay, and then use that energy during the morning or during the evening where we do not have any PV production. So the idea is to store locally the energy and then use it when there is no sun, in order to supply the nighttime loads. There are two main technologies in order to store the energy. Just to let you understand the schematic, the inverter is the DC AC, so that's the inverter that we have just discussed about. We can have the battery on the DC side. We can have a DC coupled storage system, okay? Or we can have an AC coupled storage system. Of course, there are pros and cons of these two solutions. Basically, having the having the battery on the AC side, it means that we have to convert the energy from DC to AC, so from the panels from DC to AC. Then on the AC side, we have to convert again the energy from AC to DC in the battery and then store it in the battery. When you need the energy, the process will be again to convert the energy stored in the battery from DC to AC. So of course, it means less efficiency because we have three conversions basically. On the DC side, you store the energy in a battery, and then on the DC side, and when you need the energy, there is only a single conversion. So it's much more efficient have the battery on the DC side. Sorry, and this is what SolarEdge is proposing. SolarEdge is proposing a hybrid inverter that works, of course, with the power optimizers. In the picture, you have the smart modules that comes already with the power optimizer. So there is smart modules, and on the DC side, we can connect directly a battery. In this specific case, it's a high voltage battery. The capacity is from 7 up to 20 kilowatt hour per hour. Okay, so it means that with 20 kilowatt hour, we can, let's say, manage the loads of a house, regular house during the night, and also we are able to feed the energy also in a heating pump that is on a heating pump, for instance. So let's say 20 kilowatt hour. It's a huge capacity for a house. Okay, we need to connect to the inverter an energy meter. Energy meter, the inverter has to communicate with the meter, and once there is energy coming from the grid or coming from the system to the grid, the inverter has this information in order to manage manage the energy flow. It means charge the battery or discharge the battery. Usually the maximum charge and discharge of the battery is 5 kilowatts. So with a storage battery, we can have 5 kilowatts for the house loads. Okay, this is for a single phase solution. In case of three phase, usually it happens when we have a heating pump on a house, independent house, usually, or if we have or the customer has the homeowner has an electrical vehicle, an electrical car. Usually the single phase, it is not enough. In Italy, or generally speaking in Europe, the maximum power single phase is 6 kilowatt. If you need more power, you need to go with a three-phase connection. And we have a specific solution for three-phase. It's an inverter that can manage, in this specific case, low voltage batteries. Low voltage batteries means 48 volts. The voltage of the battery is 48 volts. We can manage batteries. The capacity is from 6.5 kilowatts up to 24 kilowatt hour. We are currently compatible with LG CAN batteries and BYD batteries. So we have I think that what is important here is to understand that with this solution you can store up to 24 kilowatt hours energy. The scheme is pretty the same of the single phase. The battery is in the DC side. Is on the DC side. It means that it's more efficient because there is a single conversion. From the modules on the DC side, we are charging the battery, and once you need energy and there is no sun, you can discharge the battery and you have only a single conversion from DC to the AC. Okay, so it's a much more efficient way to store the energy. All the information regarding the PV production and the battery storage level, you can see it on the monitoring portal on your laptop or on your smartphone or tablet. Now it comes to one of very nice product that is SolarEdge introduced first, the world first inverter that integrates an EV charger. It means that this photovoltaic inverter has integrated a wall box to recharge an EV, an electrical vehicle. It means that once your inverter is in production, you can take, let's say, direct the energy coming from the sun and charge your electrical car. You have just to plug the cable in the car, and that's all. You can recharge the car using the sun. You can recharge the car. You can charge the car using the energy from the grid or from the battery. Let's assume that you are coming back from university, and you are charging your car during the night. You can use the energy coming from the batteries or using the energy from the grid. Okay, or using the solar boost mode, that is 2.5x faster charging. It means that you can, if there is a sunny day, you can use the energy from the sun, take the energy from the grid, and charge the car up to 7.4 kilowatts. So you can have an extra power and charge your electrical car faster, much more faster than a system that doesn't have the solar boost mode. Okay, these are just this is an example that in 1 hour with a regular EV charger, you can recharge the car up to from 8 to 15 kilometers capacity. With the solar boost mode, you can have in 1 hour of charging the capacity from 35 to 40 kilometers of capacity of the maximum distance that I can drive with the car. Okay, now I would like to present the smart energy solutions that, as I told at the beginning, we can, let's say, generate energy, renewable energy, but we can also control the loads in the house. For instance, we can heat the water in an electrical boiler. For instance, we can use the smart hot water. We can connect the electrical boiler to this appliance, and instead to feed the excess of energy in the grid, I can decide. So this device will heat the water for domestic use. Okay, we will heat the water. So we will use this electrical tank as a thermal storage, let's say. We can connect to the inverter smart plugs or smart switches. So we can turn on the light, we can turn on, let's say, an appliance, so we can turn on a pump, or we can open, let's say, a door. We can have the control of electrical appliances in the house. And the last that is really important is the smart relay. The smart relay can be connected to all the smart grid products that I believe that you are familiar with, the SG ready appliances, as heating pumps, for instance. That is really important to have this connection. With the smart relay, I can control a heating pump. So from the SolarEdge, from my SolarEdge app, I can turn on or turn off a heating pump, or decide to have an automatic setting that once the system is feeding more than, let's assume 3 kilowatt in the grid, then we'll turn on the heating pump in order to use that energy instead of feeding the grid. Okay, with the smart relay, you can, if you have a SG ready washing machine, you can turn on automatically when there is the sun, you can turn on that appliance. So you understand that there is a really integration from energy production, from renewables, and we can, let's say, control the loads and use all the energy that we are producing locally from renewables. Okay, this is important, not to use the grid just to produce the energy and then feed in the grid, but we can use in the house when the energy is produced. So this is the integration with the lots in the house. I would like to show you the monitoring portal using the this is, as I told you, all the inverters has the communication board that can be connected to a Wi-Fi, to a router with a Ethernet cable or with a Wi-Fi. Let's say you can connect the inverter through the Wi-Fi to the internet, and then you will have on your smartphone, you will have the daily production of the inverter, the daily consumption, so how much energy I'm taking from the grid, and in blue you can see the self-consumption. Self-consumption, it means the energy that is produced by the PV and is used once it's produced. Okay. With the power optimizer, we have a higher detail of energy production. You can see that in the middle you have every rectangle is a PV module, and you have the information of production per each module. So we know exactly how much energy was produced by single PV module. You have all the information, all the control in the app. We can have the battery level. We can control the car charging level from the smartphone. So I can decide when to turn on the car charge. I can decide when to turn it off. Yeah, all the information are in your hand, in your smartphone. Okay, I think that I complete the presentation in time. So now, if you have any question, don't hesitate to ask me.
Okay. First of all, I thank you for the presentation. I think that the eventual question from the floor will be from the electrical engineering because we have a very different competencies in our class. I think that architect or urban planner maybe are not so.
Well, we can say that we have two parts. The first one was very, very technical regarding the power optimizer. The second one, I hope it was more clear, and the concept of, let's say, self-consumption, control the load, store the energy. Let's say, if we avoid the details of how energy is produced, but I think that it's clear what is the purpose of SolarEdge is that to use the energy and to control the energy with the integrated system.
Yeah, it's very clear. I have a question. You speak about the possibility to heat water for domestic use. The heating is a continuous heating, or is like a boiler that you have a storage of water that you heat and then
so basically we have two options basically. The first one is to use a resistive load that you have in an electrical boiler, and you are heating the water with Joule effect. So just feeding the energy in the resistance, and then you are heating the water. The second way, you can use a heating pump for domestic hot water, and then you are using heating pump with a thermal cycle. And in that case, you are using a relay, and but there is a heating pump that is heating the water. Basically, we have to weigh. Of course, the resistance, it's less. You have less efficiency, of course, because it's just a resistance. In the second case, with the heating pump, the efficiency is much more higher. But it's not, let's say, it's not instantaneous like a boiler. It's, you have to heat the water. Let's say it depends on how many liters do you have, but it takes times, and it depends on the power. If you have 3 kilowatt, it takes X. If you have 5 kilowatt, it takes less, of course.
Okay, I don't know if there's some question or comment from the participant. I invite you, if you have time, to stay some more time to
Sure.
To stay with the groups in the subgroup. Maybe it's some group could be have some question, or you can suggest some solution for the project. So Alessandro,
sì, interrompo la diretta.
Ok, grazie.
Saluto a tutti la diretta.